All right, so let's talk about this review. Let's move this so I can see it a little bit. Determine the following ratios, cy to dy. Okay, so for this, am I gonna make, okay. The first thing I want to do is always make sure I have all these points sort of highlighted, even the ones that aren't really marked. So cy to dy. Well, what I do for cy is draw a little like triangle to measure that distance. Same thing with dy, but I'm going to do it in three small triangles. I know. Whoops, just about like that. Kind of went a little bit off there, made a little mistake. Well, just by this, we can see that cy is, if we call that a distance of 1, just for instance, this would be 3 times that distance, right? So the ratio would be 1 to 3. Let's make this smaller. That's better. Okay. So in the same sort of way, we can see that with CZ and CD. CZ is 3 of these triangles. CD is all 4 of them. It's simply a 3 to 4 ratio. YZ, let's see, to YC. Oh, so this is a distance of 2 versus a distance of 1, like comparable unit. So 2 to 1. All right, and last one, YZ to YD. Well, it's just 2 triangles, 3 triangles, right? YZ is 2 of these, YZ, but YD is 3 of these. So it'd be 2 to 3. All right, now we're given a few other things. Given these lines AB and EF, determine the points of point X such that the ratio of these of AB to XB is 6 to 1. Okay, so to do that, I want to look at, this line AB and mark down all of these points along it that I can find. That might make it a lot easier. All right, so I want this ratio of AB. This is the entire line, so like the whole to part ratio to this part XB to be 6 to 1. Okay, so that means the distance, I need to find this point X such that it's the distance between X and B is 1/6 of the entire thing. We know this is the entire thing right here. So let's see. Well, we have 1, 2, 3, 4, 5, 6 units. Oh, that's convenient, isn't it? So just one of these units will be where X is. That's what? -3, -1? Just like that. Point Q, such that the ratio of lengths AB to QB is 12 to 8. Okay, we're still on this line AB, but when we're given this ratio 12 to 8, we can do something about that. 12 to 8, that has a common factor. If I divide both of these by 4, I will get 3 to 2, right? By dividing 4. So let's see. A 3 to 2 ratio for AB to be for every 3 units that AB has, QB needs to have 2 units. Well, so 1, 2, 1, 2, 3, 4, 5, 6. So there are 6 units of AB. So that means if we're going to have for 2 for every 3 units, that means if there's 6 units for AB, QB is going to be 4 units. So Q is going to be right there. I don't know the coordinate. I can't read it. All right. Point R such that FR to RE is 1-to-1. So that's on this line now. 1-to-1 just means we're splitting this guy in half. Splitting it in half means midpoint formula. Midpoint formula, if you don't remember, whoops. If we have 2 points, x1, y1, x2, y2, it's just the average of these x's and the average of these y's. Average of the x's and average of the y's. Well, what are our x's? Let's see. Let me also erase so I can. So I can make some more room. Well, let's see. This point is -8, -8. And this point is 7, -5. So it might help if you label these x1, y1, x2, y2. So then this will become, okay, -8 plus 7 over 2 and -8 plus -5 over 2. I'm running out of room. I can't really close my parentheses. Well, -8 plus 7 is -1, -1 over 2. And -8 plus -5 is -13. I'll just leave that as a fraction, -13 over 2. So that would be the point for that. Now we're asked about point S, such that the ratio of FS to FE, okay. FE is this entire line, right? So the ratio from this portion to the entire thing is 1/3, is 1-3. So that means this segment, the length between F and some point S is going to be 1/3 of the entire length. The entire length is going to be 3 times this F and S length. And that's why I found plotting these points is useful. I think I forget exactly where it was, but this fell on a point. Might have been right there. It fell on a point very cleanly to drop this thing into 3 different segments. So if I want FS to be that shorter segment, it's going to be right here, right? It's going to be, this will be one of those segments. So whatever that point happens to be. All right. Let me zoom out a little bit. All right, given the line segment AB below, answer the following questions. What is the slope of AB? Well, slope is just rise over run, remember? And this slope, I believe, I'm having trouble counting now. If we were to draw a slope triangle to do that, you'd go up 8 and over 7. So it'd be 8 over 7. Just count them out. Draw a line that's parallel to it. Okay, let me just give a rough sketch. What's the slope of that line? Well, by definition, it has to have the same slope, 8 over 7. Draw a line that's perpendicular to it. Ooh, okay, got to make a right angle with it. What is the slope of that line? Well, that you just got to remember 2 words: opposite, reciprocal. Opposite meaning it's going to be negative. Reciprocal meaning we swap the numerator and denominator. So it'll be -7/8. Simple. Goodness.
Good afternoon, Fullville students and staff. At this time, I just request that if you have your car parked in the current bus loop or the parking next to the cafeteria or anything like that, you can move your vehicles to the south lot. So that way we can prepare for the groundbreaking ceremony this evening, using the bus loop as overflow and reserve parking. So we're going to clear out that area. Thank you.
Sorry about that. All right, last thing, use use coordinate geometry and characteristic of quadrilaterals to explain what type of quadrilateral this guy must be. Well, for that, we're going to be doing two things. We're going to be finding each of these distances of these red lines. And we're also going to be finding each of their slopes. I have a terrible copy right now of this thing scanned. So we'd find the rise over run of each of these. With these triangles. We'd use these triangles now to find the rise over run and to use Pythagorean theorem. We'd use it in both ways to find out, all right, what are these distances? Are they the same or are they different? And we also use those slopes to see, or do we have any right angles? Do we have any parallel lines? I can't do that right now because I just don't have, I can't see it that well. But this thing happens to have two pairs of parallel lines and two pairs of right angles, two pairs of opposite reciprocal slopes. And all these distances happen to be the same. That makes it a square. So the perimeter is simple. Using Pythagorean theorem, we'll find all four of these sides, right? Just add those four up. Just add them up. For the area, there are two different ways we can do that. We can either find the area of this entire square or this entire region and subtract out the area of these triangles. We could do that. But once we found out this is a square, can't we just multiply the length of this side times the length of that side? Of course we could. That is for a square. For other ones, you couldn't do that. All right. What type of triangle is this triangle? Explain how we know. It's ACD. Man, this is a bit rough. Let me get my straight line tool. ACD, so we're forgetting about B. Didn't know these were going to be that big. All right, so if you just guessed once you saw this, then I'm sorry, you're just wrong. Like, you can't do that. What you need to do is, again, make more triangles, triangulate, make this. So we have this point. Let's see, this is -1, -2. This is 4, 2, and this is -5, 3. And the way we'd find out what these distances are is, again, by effectively making more triangles to effectively force upon this the Pythagorean theorem. This has a distance of 9. This is a distance of 1. This here is a distance of, let's see, from 2 to -2 of 4. This is a distance of -5. This here we have one more triangle. Is another distance of 5. This is a distance of from -1 to -5, a distance of 4. So there's, let me get to my highlighter. We need to find the area of the length of these three sides by using Pythagorean theorem 3 times. One for this triangle to get that hypotenuse, one for this triangle, and one for this triangle. So we do that 3 times. So for the purple, 1 squared plus 9 squared is equal to c squared, right? Well, 1 plus 81 is equal to c squared, right? So I'll just say c is equal to the square root of 81. Sorry, 82, excuse me. With the other ones, we have 5 and 4 for both of them. We're getting the same side. 5 squared plus 4 squared is equal to 5 squared plus 4 squared, right? Let's find out what that is. (25 plus 16) is equal to c squared. So c is equal to the square root of 41. You get that for the blue edge and for the like darker edge. You get the same distance. So this thing has two equal sides. If it has two equal sides, it's isosceles, right? If it has one equal side or no equal sides, it's scalene. If it's all three equal sides, it's equilateral. I'm sorry if this was a bit rushed. I hope it helps. I will see you all tomorrow.